Imagine trying to FaceTime your best friend on Mars, only to find the call keeps dropping every time the planet spins away. That's the daily headache NASA faces, and Blue Origin just raised its hand with a bold, possibly game-changing answer. The Mars Telecommunications Orbiter, MTO. But here's where it gets controversial. Some veteran engineers argue that handing this critical relay job to a private company could shift the balance of power in deep space communications forever. Ready to dig in? Blue Origin, the Kent, Washington-based aerospace firm founded by Jeff Bezos, has spent 2 decades perfecting heavy-lift rockets, precision landers, and interplanetary transports. Now it's leveraging that same hardware DNA, specifically its versatile Blue Ring platform, to craft a spacecraft that could become the Red Planet's first privately owned cell tower in the sky. Scheduled to support NASA's 2028 Mars campaign, MTO isn't just another satellite. It's a full-blown communications backbone designed to keep Earth and Mars chatting 24/7. What exactly does backbone mean here? Picture a high-speed Wi-Fi mesh that never sleeps. MTO will park itself in an optimized orbit and unfurl multiple steerable antennas. Think of them as cosmic laser pointers, capable of beaming data back to Earth at rates high enough to stream 4K video. A broad beam umbrella covers wide areas, while a handful of pint-sized UHF relay CubeSats will zip around in low Mars orbit like helpful messenger pigeons, ensuring older rovers and future landing craft never lose signal during the nail-biting 7 minutes of terror descent. And this is the part most people miss: the spacecraft's hybrid propulsion system. Instead of relying solely on traditional chemical thrusters, which guzzle fuel and limit launch windows, MTO marries a high-efficiency electric engine with a modest chemical kick. Translation? It can depart Earth during less than ideal alignments, cruise using solar electric power, and still arrive at Mars with fuel to spare. That flexibility slashes mission risk and opens the door for more frequent flights, something traditionalists say bends the laws of orbital mechanics in ways we've never tested at this scale. Payload capacity is another jaw-dropper. MTO can haul over 1,000 kilograms of instruments, antennas, and processors, roughly the mass of a grand piano, into Martian orbit. Inside that cargo bay lives a mini data center, edge processors, terabytes of solid-state storage, and onboard artificial intelligence that can prioritize which images or sensor readings get the express lane back to Earth. Imagine a rover snapping 1,000 photos. Instead of waiting for a human on Earth to sift through them, MTO's AI could instantly flag the one rock that looks suspiciously like a fossil and push it to the front of the queue. But let's stir the pot. Critics ask, should a single private entity control the primary data pipeline for humanity's most ambitious planetary mission? If Blue Origin owns the switchboard, who sets the rates, the data priorities, or the security protocols? Supporters counter that commercial innovation is the only way to keep costs low enough for sustained exploration. So, dear reader, where do you stand? Should NASA lean on private networks, or is a publicly owned relay the safer bet for our multi-billion-dollar Mars dreams? Drop your take in the comments. Agreement, outrage, or brilliant middle ground solutions are all welcome.